Okay, let's begin. Well, welcome. We're going to be talking about SAP on the Amazon Web Services from an architectural overview standpoint.
So we'll go through a couple of quick bios. My name is Rodolfo Bejarano. I am actually Costa Rican who lived 5 years in Prague working for SUSE, and then I moved to the US where I currently have a solutions engineer role for the company.
I'm Rick Spurgeon, and I've been around for a long time. The most relevant experience that I have to this context is prior to joining SUSE 4 years ago, I was with Red Hat for 10 years, and currently I'm working as a partner sales engineer with SUSE based in the Dallas-Fort Worth area. So why is this important? Well, there's a growing utilization, as I'm sure you're all aware, of public clouds. This is as a result of the fact that you can use the public cloud for your infrastructure using operational expenses as opposed to capital expenditures, so that you can pay as you go, and your infrastructure is based on your usage rather than putting up a lot of money up front and then having the usage over time, amortizing the cost. Also, we have the reliability of the cloud helps translate into high availability. We can show you a way to take that one step further, but in and of itself, it looks like it has a sufficient resiliency to be highly reliable. It's very scalable, as you're all aware, and there's no long-term commitment, and it has a global reach. So many SUSE customers either use or plan to use public clouds, either as their primary IT infrastructure or as auxiliary IT infrastructure. Perhaps they use it when they reach peak processing periods and their workload is much greater than their current capacity in their data center. So the agenda is to talk about the SUSE and Amazon Web Services Alliance, to talk about SUSE solutions on AWS. We talk about how to minimize downtime, in other words, go beyond what AWS gives you just as a result of being the environment that it is, and also SUSE supported AWS specific agents that are available.
Sorry Rick, we are not in love with our voices, so please ask questions. That'll make the session a lot better and a lot more interactive. So please stop us at any time, okay?
Please do. It makes the presentation a lot more interesting too, I think. Well, as you can see, since 2010, there's been an increasing customer adoption of our products on AWS, beginning with just the basic availability of SLES on AWS back then, and continuing on with SLES for SAP and HANA and support for the X1 and X16, or X1E rather, versions that are on EC2, the EC2 instances. And our product offerings have multiplied as the customer adoption has increased. SUSE and AWS, well, let's tell you a little bit about it. We have 9 years of joint engineering between their engineers and our engineers. We think the cloud can be trusted for mission critical workloads because with high availability solutions, because those solutions are custom built for the AWS platform. And also their seamless support. You can call it AWS, their support team, and they know all about Linux and SAP, and they're prepared to help you with any issue or problem or question that you might have, just like we can if you call SUSE about the same type of issues. So, it can go either way really. You could call them or you could call us, unless it just pertains to Amazon Web Services, in which case they would be the best alternative.
So does this mean even though the customer purchases the priority support, for example, they open the ticket with AWS and AWS is able to resolve many of the SUSE specific cases?
Yes, and the way that would work, and correct me if I'm wrong, Rodolfo, is if it's pay as you go, okay, from the marketplace, certainly they would be the first line of support for just about everything really. But if it's bring your own subscription, that's where the dichotomy would sort of begin, where if it's a operating system, related, or like our HA, if it's based on that, some problem with the HA, then you might call us, first, as opposed to AWS, but because we're providing your support.
But I think that's what you're referring to. If you purchase the subscription from us directly and do the bring your own subscription, you would call us at that point.
That if I'm a customer, right?
Mm-hmm.
In your previous slide, you said that you have a AWS engineers trained
Yeah.
on SUSE. So my point here is that if I'm a customer, I purchase, let's say, AWS service on the SUSE.
Yep.
I do call AWS, right?
Right. If
Because I don't know
you
where the problem results are, right?
correct.
And then let's say that whether it's even it's a SUSE problem,
Mm-hmm.
maybe AWS engineer able to resolve it. If
Mhm.
not, then do AWS engineer ask customer, hey, now you go to SUSE,
No.
or they internally figure out with SUSE team and give one-click support kind of thing.
Exactly. So how it works is the same as with OEMs. So level 1, level 2 is handled by AWS engineers. If it goes to an engineering problem, they basically talk to us in the background. So it's transparent to you. So if there's a bug that's found, they just basically open a ticket directly with us. Our engineering fixes it, provides the bug, and AWS provides the bug. Or actually what AWS will do is update the images, and then you just spin up the new images per se, or something like that. So that's how that would go.
Okay. As you can see on this slide, 90% of the deployments of SLES SAP with HANA are on our product SLES for SAP. 100% of the installations of that on Power are using SLES for SAP. 70% of the SAP applications on Linux use our Linux, and 100% of the Business One. Why is that? Well, SAP uses SLES to develop on. Our cloud, their cloud, is based on our SUSE OpenStack cloud. We have 18 years or 19 years of working with them, with people on site at Waldorf, Germany, where the SAP Linux lab is, working with them. So they know our products the best, they develop on it, and they're best prepared, I would think, as a result to make sure that their products work seamlessly and with no problems on our platform. Okay, as a result of everything we were talking about, we have Amazon Web Services and SUSE. We have high availability solutions that are co-engineered there in Waldorf, Germany, for SAP HANA on Amazon Web Services. You can rapid provision. You can create new SAP systems through AWS QuickStarts on SUSE, Linux in less than 1 hour. And I was talking with Rodolfo, and he says he's done it in 20 minutes. It's pretty good.
So our lead architect has joined. Thank you for coming, David. I wanted to give you a hard time about it. What's the fastest that you've deployed a QuickStart?
I don't know, about 30 minutes, but it takes,
In that class, we did it in 30 minutes.
it takes about 30 minutes.
Okay.
I mean, it all depends on spinning up the EC2 instances.
Right.
So it's all automation, but it's pretty specific.
SLES was the first supported OS for SAP HANA on AWS, and the first on the X1 instances. There's a low cost of entry, 2 terabytes for 40 hours costs less than $700, and you could achieve up to a 72% discount on X1 with reserved instances. Now, SUSE solutions on AWS. I'm sure you've seen this diagram already, probably several times during the day. You probably see it several times more before the conference is over. And basically this shows the interrelationships, between our products and how they work with one another, and what all they are, of course. SUSE solutions are optimized for AWS. We have a public cloud module which makes SLES cloud aware. You can do a lot of the functions that you would do through the user interface, using commands on the command line. We have a public cloud procurement options. You can bring your own subscription, where you buy a subscription for a year or 3, for example, from SUSE, and then you use that on, on AWS, or you could just pay as you go from them, where you pay by the, the hour, I think, is the way they would be the increment. Pre-configured value adds in terms of HA. We already have that set up, pre-configured, easy to put in. We know it works. And network optimization, a lot of different things have been done for you if you're using Amazon Web Services for, your SLES for SAP. Let's look at how you would tune the environment. SAP Tune is the utility you would use, and it uses the TuneD service. And you would key in SAP Tune, some solution that you would choose from this list that you see below, and then you'd say apply, for example, SAP Tune solution apply HANA if that's what you wanted. And of course the list would tell you all the available SAP Tune profiles that are out there.
Has anybody here used that tool? All right, some of you. It's quite useful because it basically optimizes the system for any of these applications and or databases. So it's a tool that is definitely a differentiator that we have. So if you didn't know about it and you're doing some of these databases or applications, whether it's NetWeaver or a HANA database, make sure of it because you'll definitely benefit from it.
Okay, so again, your options are pay as you go or bring your own subscription. If you pay as you go, it's an additional hourly subscription cost based on the virtual machine size. It's like a utility. It's like the electric utility. You just pay for whatever you happen to use. The cloud engineering team, the SUSE cloud engineering team, maintains the image, okay? And it's registered with the local region update server. So all the update infrastructure that you would normally have is provided for you. But you can buy your own subscription, bring your own subscription, and you're going to use that in the public cloud instead of the pay-as-you-go. And the support agreement transfers to the public cloud, and additional subscriptions are available. Excuse me.
Yeah, so a lot of people, a lot of customers use the bring your own subscription if, for example, they bought 3 years of support, right? And then halfway there, they decide, oh, we're going to change our strategy and go to the public cloud. They don't need to make an additional investment in pay-as-you-go. They can basically take those subscriptions they already own and utilize them in the public cloud. So that's what this is all about.
Okay. And the last point was, when you bring your own subscription, you provide the update infrastructure, which of course we have in terms of, well, there's several ways to do that. So launching SUSE on AWS. Well, the first 2 examples here are SLES and SLES for SAP, and they involve using Marketplace, so you're choosing a Marketplace Amazon machine image. And the third one is where you bring your own subscription, and you're going to use a community AMI, and then you're going to register it to SUSE, sec.suse.com or to your SUSE manager. AWS QuickStart. This is a deployment guide that's available and tells you how to, basically would tell you how to do this deployment in 20 minutes. Is that
Yeah, has
the case?
anybody used the QuickStarts? You have? It's cool. So anybody here familiar with OpenStack heat templates? Okay, so this is basically that for AWS. So what the QuickStart deployment will do is it'll actually build the infrastructure for the to HANA. Let's say you're doing a HANA deployment. So you would use the CloudFormation template to build the infrastructure behind it, and it will also go and install the HANA database on it as well for you. So it's an automated process where you basically just give it a list of items of where to go get the installers for HANA and your usernames and passwords and things of that nature, and it'll go and execute it for you. So it's a pretty cool tool. If you haven't used it, again, something you might want to try.
So now let's talk about minimizing downtime, and Rodolfo is going to lead us through that. Would
So
you like
yeah,
to switch?
no, that's fine. Talking
Okay.
about minimizing downtime. So we all know Murphy's Law, right? Something bad is bound to happen. So why not cover yourself, okay? The way we see it is if you do have a contingency plan, you can minimize Murphy's Law, okay? So the way we do that, and what I will focus is on the HANA, high availability. So we have provided a number of firsts, not only with SAP, but on AWS as well. One of them is the automated SAP HANA failover, in which the HANA replication mechanism is done by SAP, but what we do is create a cluster of 2 nodes and basically automate that process of making your secondary node your primary if a failure occurs on your primary node. We do support a number of HA scenarios, ranging from NetWeaver, if you use NetWeaver, to a HANA scale up and a HANA scale out. So again, a number of different scenarios. We will go ahead and focus on the scale up in our case, where again, what I was talking about was you have a primary HANA deployment, the HANA system replication, which is an SAP component, is basically replicating your data of your database across to that secondary node. If a failure occurs at any point in time on your primary node, our pacemaker, or actually our resources, will go ahead and check that if it's working. If it's not, it'll basically migrate your services over to that secondary node. Okay? Any questions so far? Okay. So again, I probably stole my own thunder there, because this is exactly what I just talked about. Yeah, we automate the takeover of that system, which again improves your SLAs. And the way it works is there is a virtual IP, which is what you point all your applications to. And once a failure is found, that slave becomes the master, or primary as it's called, and it moves that virtual IP from node A to node B. We will go through some of those AWS specific agents, such as the fencing mechanism, which is not the traditional fencing that we use on bare metal systems. It's a HANA specific one, as well as the VPC Move IP. What's the name? Resource. All right, so we support all of these scenarios. Performance optimized, you basically have a dedicated big node, or 2 nodes, I should say. There's also the cost optimized scenario, where on that secondary node, you can use for things like QA. So the replication is still happening, but your data is not active. So this one, like the name says, it's cost optimized, because you can do more stuff on that secondary node. It's not idle completely. But in case of a failure, it'll turn off the QA stuff and start bringing all the secondary HANA database live, so brings it up to memory. There is multi-tenant, which you can have. It's basically like, think of it as a containerized space, where you can have different systems within your nodes. And then again, scale out, which is the most expensive one, where you have a cluster of clusters in essence. And once you don't have quorum in this cluster, that's when your virtual IP gets moved over to that secondary cluster. Okay? Any questions on any of these? No? You've all seen this slide probably as well.
You say stop not covered, so that code scenario is not covered, or what is the meaning of stop not covered?
Not covered in this presentation, because you can't do this, right, David?
You can do scale out, but it's not covered
In this presentation, it's not covered, right? But I just wanted to make sure that it is supported.
That's why it says not covered instead of not supported.
Thank you, David. That was smart. So I already basically went through this one. So it's, again, both databases are up in memory, so the takeover, it's a lot quicker, and therefore it's called performance optimized. The minute it fails over, it just basically needs to make that node B the primary HANA database, and make the other one the secondary, and that's about it for your takeover. Okay. There are some prerequisites that you need to do this for you to be able to do this in AWS. So you need 2 nodes with the performance optimized configuration. You will require the HA components to be in place. Do we support 15 yet, David? So 15 is also supported. I guess we can update these slides, but 12 and 15 will support the AWS Stoneth method. Anybody familiar with what Stoneth stands for? Not you, Todd. Very good. So Stoneth stands for shoot the other node in the head, and that's the way that we fence a system or a cluster, in the case of scale out, from trying to reactivate itself. Okay. Until you actually clean that shot to that node, it will never try to come back alive until you've actually figured what was wrong with it. Okay. That first one is critical. I've ran into multiple issues because of time sync problems, and I'm sure you all have encountered that at some point in your careers. So that's a very critical one. And I guess that's all I will say about that. So again, going to the AWS specific ones. We will cover the top 2 in this presentation. But there are others, like Route 53 agent, as well as the EFS and file system agent that we will not talk about today. Are you talking about this in any other session?
So there's a 545 session
Okay.
where they're going to cover the NetWeaver stack, and that's really where the NetWeaver application, that's really what that is covering.
Okay, so if you're interested, is it right after this one? Oh no, it's later, right?
545.
5:45, and you know the name of that session? We'll let you know. But if you're interested in those AWS specific agents, there's another session that you can attend to get details on those. For our specific case, like I said, we'll focus on basically what each agent is, as well as some recommendations and some known problems that by us listing it here, you may avoid when you're trying to do this yourself. So I already touched on this a little bit. The EC2 Stoneth agent, basically what it does, it fences nodes that are not behaving accordingly or as expected. Okay, it's located in that directory, and by the way, you will be able to get the content that we're showing in every session. I was told in a week or 2, so you will get access to all this. No need to memorize it right now. So yeah, again, it fences the node that is misbehaving and disabling it from trying to come back alive and causing more problems. So requirements for operation, it's basically using AWS CLI. It is very powerful because you can definitely mess up your cluster if you're trying to do things inappropriately with it. Yeah, so it's important, this point is very important, that the agent has to reach the EC2 access point, as it requires internet access through HTTPS, okay? And again, AWS calls have to be successful. There is an AWS authorization that is required. The instance ID needs to be known after creation. Again, the regions, account IDs, and instance names need to be 100% correct. Otherwise, it'll try to look for something that's non-existent. Like I mentioned before, it's quite powerful. If you do not configure this properly, you could have 2 cluster members that can kill each other. It's not something that ideally you want, but I will admit I've done it. So it's out in the open now. All right. Common configuration mistakes. So again, as I mentioned before, the EC2 tags, name tags, is critical. If you don't have the correct ones, it'll fail. If you have a problem on your STONIF policy, it'll fail. Yeah. Is this resolved already, David?
Yes, so that's fixed. A lot of these configuration mistakes, you might want to repeat this. They're not necessary. If you follow the QuickStart guide, you know, it's deploying correctly. A lot of this happens if people
manually
make manual edits or they make changes to the settings for whatever reason.
Okay, so the comment is, if you actually run through a QuickStart, these problems will not appear. These are common mistakes that people make when trying to configure it manually. So just something for you guys to be aware of, okay? Why would it show some false positives, okay? If someone adds characters like that in the region, have we fixed that yet? It wasn't me. I mean, okay. All right, so there's no internet access is another false positive, because it's thinking it's not actually reaching that when it's actually there. And then AWS needs to throttle EC2 API calls, okay? So the next one, the next agent I'm gonna talk about is the one that actually moves that IP address from node A to node B to make the magic happen. And that is called the AWS VPC Move IP. So within a specific region, you have multiple VPCs in AWS. And this basically allows you, again, to make that change of that virtual IP from your node A to your node B in case of a failure. Okay. Requirements, again, AWS CLI. The agent has to reach, once again, the EC2 access point. Pretty much it. Things to consider. So, as the same with the STONIF mechanism, if you actually don't configure this right manually, things may move to a system that is not ready to take the load. So yeah, it's a very powerful tool and privilege, I should say. An important one to mention is the overlay IP address must be outside the VPC address range to reach both availability zones. Okay, so that's key. In conclusion, or I'll back up actually. Are there any questions for David? Sure, go ahead.
So failure of A occurs, goes on AWS versus bare metal on
How to recover?
how to recover and move that IP address back to primary. Normally with bare metal, it's up to you, the administrator, to say, hey, he's ready to go again. Is there any difference on that on AWS?
So there's no difference. It's just you do it through this AWS agent, and please correct me if I'm wrong, David. So the same way we would do it on bare metal, you would do it using the AWS VPC Move IP.
Well, to fail back, you fail the resource.
Right.
It's a resource agent, so you fail it back to the other node, and you basically move the resource group back over to whatever node you want. But to be honest, the way you
He's a superstar. To be recorded, David.
All right, are any other questions?
That was a good one, yeah.
Yes, are those two agents part of pacemaker or
So
in mainstream or it's?
They're part of the HAE module, yes. So they're included as resource agents and fencing agents, which with SLES HAE, the HAE module, but the the SAP agents to monitor the topology, to monitor the health of SAP HANA, that's available only in SLES for SAP.
No, but I mean, is it included in mainstream pacemaker?
Oh yeah,
Yeah,
no,
yeah.
absolutely. Everything that we do is submitted upstream.
good question. Yes, sir. Oh no, that's the camera guy. Sorry. Sorry, man. I thought you were raising your hand. Any other questions?
I do want to point out, I know that with the overlay IP address, so in a VPC, when you have availability zones, you have to have different subnets per availability zone. So you can't overlap subnets per availability zone. And with AWS, I don't know if everybody's aware, but an availability zone is separate. It's a separate data center.
Mm-hmm.
It is a separate environment. So you have to. The reason it has to be an external IP is because it has to be an IP address that can live on either of those availability zones. And it does set up a separate routing table. And if you follow the best practice guide, even with the QuickStart, they've actually, Amazon has made some modifications to where you can be specific about which routing table to edit. Because that was a big question that some customers had. They were like, well, we have these nodes and they're able to make modifications to all routing tables. So in this deployment, you actually have a specific routing table so that the two nodes can communicate with each other. And that's really what is being edited and modified.
How do you handle overlay IP address across regions?
You don't. We don't have there's not a resource agent right now that automates like a disaster recovery.
Are you working on something like that?
I mean, I think I'll say I don't know to that. I know talking to AWS right now, a lot of what we're doing is I mean, we have a lot of documentation around setup. We're really focused on management, enabling a lot of customers, and right now, failing from region to region, just the latency involved for like a active-active environment. That's not.
So that's what I was going to say. That's probably more of an SAP requirement and or block to
Yeah.
this feature than a capability that we could
And I think
possibly pull off.
what if SUSE were to ever involve like a resource agent that allows failover from a primary to like, or from to a DR, kind of like that type of failover, I think that would come into play, but I don't know if the Move IP resource agent would do that.
It actually comes down to latency, as you said,
Yeah.
because you're trying to replicate across, yeah, so.
Yeah, well, it was about the virtual IP. So you're not using like elastic IP. You use
No.
the internal IP and you modify that routing table.
Yeah, so-
You set a routing table
So
to the cluster nodes and you modify it when it's a failover.
yeah, so if you set up your, like with the QuickStart, it sets up the private IP address, like the default subnets are 10 dot whatever subnets. So on what you would do for the overlay IP is like create like a 172.21 whatever. So it's a private IP that doesn't fall into the range of that VPC, because what you don't want to do is create an IP conflict.
And then what you do is change that routing table.
Yes, so the Move IP agent, when it detects a failure, it actually creates, changes the route it changes the route to the interface on the second node. So you have E&I adapters, they're network interface constructs within AWS EC2 instances. And what you're doing is basically routing to the network interface and just moving that IP back and forth.
Great questions. Any other? All right.
All right, thank you.
Thanks, David.
I don't know. Yeah.
So again, in conclusion, public cloud usage, as Rick showed earlier, and adoption has grown for a number of reasons. We are here to talk about SAP. So SAP runs really well on the public cloud in general, but in AWS in particular, because of all these, yeah. Sorry, I didn't say that. It wasn't me. And there are multiple strategies and methods that you can utilize in order to achieve HA. And again, we showed some, and the title might have been a little misleading because we really didn't go deeper into the architecture as I would have liked. But we gave you a quick overview of things and how those are utilized within AWS. So there's some additional documentation in case you're curious about this stuff. And basically, again, ask for, if you have any questions, you can always send to this email address, which reaches David directly. No, I'm kidding. Yeah, but yeah, it's all AWS experts. So if you have any questions, feel free to reach out to aws@suse.com. It can't get any easier than that email to remember. And basically, if you don't have any questions, we'll give you back some 20 minutes of your day to get some coffee or something. Thank you very much.